Oh, okay. It's already run without my help. First of all, I want to say thank you for having possibility to provide this talk and say thank you to organizers for having such a good event. And let's start our conversation. At the first point of view, I want to say that this talk wouldn't be mostly around models. It would be about some tricks which we can do with data labeling and actually utilizing already labeled data set. So I wouldn't touch really deep during these use cases some models. So yeah, it's kind of disclaimer. And second disclaimer, there are no, let's say, silver bullet for this question. So I will provide some cases which we had in past. But of course, it could happen that for your particular case, all this mentioned approach wouldn't work. So let me start from short bio. So I'm working in data science and machine learning more than 20 years. And actually, I joined EPAM around 2016 and working here more than 6 years. From this particular year, I'm a part of Serbian EPAM, and before EPAM I mostly worked in computer vision domain and had a little bit experience in time series. But after joining EPAM, I really had possibility to work on different, let's say, type of a project and improve my knowledge and experience in recommendation system, NLP, and of course computer vision and time series as well. So let's start our talk. So let's imagine that we are starting deep learning project. Yeah. So what do we want in ideal case? First of all, of course, we are solving our problem for business. Yeah. All models should be, let's say, util for some customers. So having good business understanding is a must. Second point, it's having good data quality because the first law of machine learning, garbage in, garbage out. But also, if you're solving specific task which need to utilize labeled data, you want to have good representative sample, which was properly labeled with good quality, or otherwise you have possibility to do this labeling, you have enough budget, you have established flow, you have everything to have normal amounts of labeled data. But actually, it's not always true, unfortunately. So sometimes you could start small projects, working with startups, working with not typical problems, and you don't have such a possibility. Also, nowadays, as maybe you know, we have many pre-trained models, we have open data sets, and actually sometimes you don't need to have data set which was labeled specifically for your problem. And also you can utilize many tricky techniques like after labeling, label propagation, which I will show on some NLP case later. So you can think that actually EPAM is kind of big company, why we could have such a situation. First of all, not all our projects related to big companies. Sometimes we can help some startups, sometimes we can help some small department of big company, and these guys don't have enough budget to label data. It could be some new customer, it could be situation when we worked with this customer previously, but we trying to, let's say, work for new department of same customer. And in this case, oftenly we could have situation that we don't have budget for labeling data, and case could be really specific, and because of that we need to do some tricks to be able to deliver some value to our customers. Today I will describe briefly 4 use cases, 2 regarding computer vision, 1 about audio and sound processing, and the 4th one about NLP, to be more precise, entity extraction. So let's start with, let's say, juicy part, computer vision. So about 7 years ago, when I worked in small Russian-based company, some startup reached us and said, okay, guys, we have about a month and we need to provide some results for our potential investors. And what they want to do? They want to solve a simple problem. So maybe you know there is such a game like darts. Yeah, I guess in Serbia it's kind of normal thing to know. And they have about, let's say, many hours of this darts game, and they wanted to build solution which can support automatic scoring in these darts. So we talked with guys and we committed, okay, we can provide some solution. We brainstormed inside our company, and initially we decided to go by classical computer vision approach. And we did really good solution on segmentation. Here it's one example of code on PSC stage, which I had about segmentation of board. We have good solution on morphology level for detecting particular score and difference between darts. But unfortunately, we tried many classical approach for detect board stably, and in the moment when I already wrote maybe 5 rules to, let's say, establish all use cases, I decided to try to do some deep learning and approach, because actually it should work more stable and better from scaling perspective. But there are some problems, yeah? As maybe you know, there are no such data set around darts. At least there were no such data set at the moment which we did this project. It was about 2015. And actually, we had initial intuition that, again, if you ever worked with transfer learning in computer vision, especially with object detection problem, you know that actually typical object detector can really fast learn bounded boxes, but sometimes can really slowly learn classification. So we had the idea, let's label few samples and run, let's say, train on this small set, adding some known data from Coco, and we would have something good. But after that, we realized, oh, actually, Coco dataset doesn't have this exact target, I mean, darts board. And for me, it looks like, okay, darts boards is similar to clock and something like this, because you have circles, you have some, let's say, darts which similar to clock's disposition, and actually you have numbers around. So we just did simple thing. We use faster CNN, run our darts game video recording through this, and actually realized that for 95%, we have relatively good results by only this clock model. And we labeled around, let's say, 50 images, add this to network, and we achieved fantastic result. So afterwards, we realized actually, and myself as well, that this pre-trained model can do much more than you can think about them, because for this case, yeah, we can solve really strange tasks which shouldn't be solved by this model. And next case, from this perspective, could be even interesting. For this particular case, another startup reached us, and we worked on a challenging task. It was about digital farming. To be more precise, startup wanted to detect weight of the pig. And same story, we don't have enough labeled data. We have about, let's say, 10 video recording which was labeled really, really poorly and partially, and have many hours of this recording of different pigs from different angles. And our customer wants for us just simple thing, provide me some segmentation result of the pig at the first stage. And what we did, as you can imagine, we just did simple thing. We run same model, and here you see results of object detection. One question to audience, from your perspective, which particular object this guy belongs? It's from Coco dataset, by the way. You maybe... No, but my question, so there is Coco dataset, yeah? And you have, let's say, labels on Coco dataset. And you don't have pig in Coco dataset, for sure, as well as darts. And I just asking you, could you imagine which particular class this guy should belong from Coco dataset? Not number, I mean specific name. No. Yeah, it's good suggestion, but I should say that it's for this case wrong. So for Coco, for model which was trained on Coco dataset, it's human actually. Yeah, for me it was kind of shock, because I know for sure what some humans could be a pig, but not otherwise. And what we did, we say, okay, it's interesting, let's run segmentation model for some segmentation, and actually you could see, yeah, so it's not finalized version, and you have some segmentation of human, yeah, in addition to pig. And pig was kind of good. So yeah, and we was shocked again, and we decided, okay, so we can generate many labeled using this network, but we had another problem. So some pigs were detected really well, but some pigs who were much red comparing to this one has poor result. So we did some, let's say, tricks with color spaces, and after that we have relatively good sample, which covers about 90% of our data, and we did some labeling exercise under the top of this, labeling about 100 of images, and we have model which works quite well. So from this perspective, I guess, I maybe repeat myself, but it's really interesting that you can use model which shouldn't solve this task, and you somehow can solve this. After that, we did some work to train simple classifier on the top of this and achieve relatively good result. So we did whole PSE almost without labeling data, using our tricks in 3 weeks, and it was kind of interesting and great result. So after this project, I joined EPAM. I had a few projects with good case when we have significant amount of label data, we have good quality of label data, but at one moment, we did good recommendation system for one huge telecom company, and we decided to, let's say, provide businesses for another department inside same company. And we don't know these guys at that moment, and they didn't know us. So they provide to us potential, let's say, list of high-level use cases, which were interested for them. And we decided, okay, audio processing, it's kind of cheap comparing to combined audio video processing. Let's having some use case around voice analysis. So we decided to impress them just using voice TV show. Our project was about extracting combination of musical and speech fragments from TV show. And actually, we decided, okay, let's do this simple job. We have about a month or 1.5 months, depending on how we will count, start the date. And we initially proposed, as I mentioned, working with audio and video stream, but we decided that actually utilizing of GPU would be hard because we don't have budget from their side. And actually we decided, okay, let's work with audio only. And doing audio segmentation, they can, after that, join video and have really impressive demo. So a few words about how we approach this task. So we approach this task as a segmentation task. So it's typical segmentation story. So you have sequence, as you can see. And actually, as a result, you have interval of music. In this case, is from T1 from T2, or sorry, T0 from T1, and from T2 to T3. So your result is these intervals, yeah? And as I mentioned, customer actually don't want to provide at the first glance as labeled data, but we remembered actually that there are many data sets around music, and especially we remember what there are such data set as audio set as a part of YouTube 8M. And we remembered that classification model, which the trained on the top of this data set showed great result. We actually tested this classification model combined with some filtering and provide segmentation result, but the result was poor. And we decided, okay, let's have this data, let's add some label data from our side, and let's have good model of segmentation. A few words about audio processing in case you don't have background. So we approach really, let's say, mainstream way of audio processing. So we convert our audio to MEL spectrograms. MEL spectrograms we, let's say, process by deep learning networks. So it's kind of, let's say, typical networks which can be used for image processing, but a little bit adjusted to audio processing files. So in this case, it was VGGish, and did PCA analysis under the top of this to have smaller dimension. And under the top of this freezing network, we just added for our segmentation purposes small and lightweighted recurrent neural network. And at the top of this network, we added few fully connected layer and CRF layer and tried to learn mask. So how this task was from form point of view. As I mentioned, you have these fragments and you have mask with 0 and 1s. And for 1, it's music. For 0, it's all over classes. And okay, I described to you how we approach the problem generally, but still problem with label data was not solved. What we decided to do? We decided to do simple things. So we have pool of positive samples, which is musical fragments. We have pool of negative samples and write simple generator. Here, guys who worked in past in audio domain or work with audio file could mention to me, okay, but if you do this on audio level directly, it would be a mess. Yeah, I couldn't agree more. But we decided to work not on raw data level, we decided to work on embedding level. For this case, everything would more or less fine. Few details about generator. Actually, we did very simple thing. So we selected some long, let's say, range, and inside this range randomly selected a particular fragment, and inside fragment randomly selected pieces which has music content inside. And just fulfill these pieces by embeddings from positive sides in the middle and negative sides is outside. So we trained such a model, and it was interesting that for typical concerts from YouTube, it works almost ideally. But for our particular use case, it works not that bad, but not that good. Because if you see some programs like Voice TV Show and similar, you know that it's not only music and speech and some of our background things, advertisement and so on. And we decided, okay, so let's improve our model for this particular case. And we did really simple thing. We ran this already prepared model to our 30 or 40 full audio files from this TV show, and we want to generate really simple thing. We want to have some points for which we predict as a positive class, but which is not positive. So we kind of get negatives, which will be hard negatives. And using this hard negative, we can really improve the model. So we added this hard negative to mentioned generator, which I showed. And after this, we achieved fantastic results. So we improve our ROC curve to 0.92 without post-processing, and after some playing with smoothing, we achieved 0.98 ROC score. So it was fantastic result, and average precision was kind of good as well. So after that, we show this result to customer, and they were happy to work with us. But they mentioned actually that we, at the moment, did not that interested in a particular voice TV show, but they provided to us many other, let's say, projects which we did in future. And maybe last case which I want to mention, it's case around NLP. So maybe you know, but I briefly describe. So what is entity extraction from documents? So typically you have some documents like PDF, images, whatever. It could be invoice, it could be loan documents, and you want to extract some entities. It could be entities as a key value pairs. It could be line items, like we have here in the table, yeah? And it's, let's say, these key pairs and line items is results of your work. So for this particular case, as a client, we have big fintech company, and in the initial setup, they had already this work done by some third-party vendor, but they were not happy about quality of this solution, and also we want to have build it in-house solution. So we team up with developer team, which was, let's say, developer team was from customer side, and data science and ML team was from our side. And we started to work, but we have, few words. So it's typical processing for entity extraction. So we use OCRing and build simple model which learns mask and add some business post-processing. Few words about model. So it's really simple. It's a two-bidirectional group plus dense and dropout. And here it's really simplification of what we need to do. So here you have 3 entities, and you want to extract bank agent, which is green, and actually want to extract QSIP value and effective date. Of course, it's really simplification because there are many different texts, but I just provide this to for you to better understand how this system could work. And actually, we did really simple processing. We use with OCR, added one-hot encoding on a character level, but added some symbols at the end of a line, and also we added coordinates because it helped us to use geometry in our features. And actually, as a target, as I mentioned, we use binary mask. This particular sample is for bank, but all of it is more or less similar from this perspective. And logical question, how we, let's say, overcome this problem with labeled data. So initially, they have only information from database. Information was something like this: QSIP, date, and bank agent, and it was values, yeah? So it's just values. You don't know exact geometry, you don't know exact values in OCR, because here we showed, again, schematically one sample, then we have one error for each of these value. And because of that, easy matching can help you. But we decided to do some sort of fuzzy matching and have data set similar to this, and just use some model, which I mentioned actually, and doing some iterative processing. So initially, we labeled this first labeled data set by using only relatively high threshold for fuzzy matching. And we did 2 things. We trained the model, and actually, after we get result, we relax our condition for fuzzy matching and have huge number of new documents labeled. And also we did some sort of pattern extraction, and under the top of this, we did clustering, and using these clusters, we, let's say, do some labeling propagation, which I will show later. And after we joined this data set, quality of our solution has become better. So after, let's say, our initial phase of a project, which was about 6 months, we reached really good result because we achieved around 70% of automation. So to be more precise, automation, it's then you extracting all entities without human intervention. So previous third-party solution gave similar number, but we were able to provide results without using, let's say, any labeling, and it was already a good result. After some iterative improvements, we achieved more significant results, and actually at the moment this solution works much better and for much more products inside this company. And speaking about labeling, yes, I showed our initial iteration what we also did. So I mentioned about labeling propagation, and key idea was really simple. So you sometimes have results when your model didn't provide you entries correct, and you took this result, and we did actually clustering using embedding of these documents, and clustering was done by HDB scan. And based off clusters, we selected specific points from these clusters and showed these points to domain experts. Domain expert labels these points, and we did label propagation for these small clusters and enrich our data set a little bit more. So this approach was helpful for us as well. So, sorry, what I want to summarize, yeah? So in general, as you can see, not having good quality of labeling at first iteration, not having good labeling budget, not having big data set pre-trained or let's say labeled for your particular task, it's not the end of the world. Plus, sometimes even if your business task is really not typical, you could achieve great result using some pre-trained model, using some tricks, which I mentioned, but you could, let's say, imagine many over. So nowadays, we have more and more development of this pre-trained model, developing of open data sets. So I guess in 5 or 10 years, it would be even much easier to do tricks which I mentioned. So yeah, you have much more possibility to do some job. Of course, we should think about after labeling, think about labeling propagation, think about how already pre-trained and working model can work on class similarity level. And here actually I want to say that I didn't mention a lot about few short learning and zero short learning, which could be another option, but we didn't use them on particular project, and I decided to not include. Plus, also oftenly combination of heuristics, already working model on dirty data could help you if you combine these and doing some work on labels. But let's be fair. So if I, as a data scientist, starting new project, in ideal world, as I mentioned initially, I want to have good quality of data set, normal budget for doing this labeling. I want to have established process for this. Of course, this trick could work, and I showed that for some project, this trick worked. But nevertheless, the most important part of project anyway would be done with situation where we have good quality of labeling, good quality of data. So yeah. That's pretty much all what I wanted briefly describe to you today. By the way, this is our PAM site, and it's my contact. Feel free to reach me out with questions maybe and suggestions. So okay, thank you very much.
So, do we have some questions? Let's see. Anyone?
Ah, yeah, okay.
Okay, there's the question.
I mean, maybe it's not a question. I just wanted to give you an example on another ideas, how people can use synthetic data in order to have some labels. So I would suggest people when they are doing some kind of natural language processing stuff, just use GPT-3 to generate data and use humans to annotate it after that. For instance, we've been developing some kind of summarization model, and you have to have articles and summaries. So basically, we've used GPT-3 to generate summaries, but using GPT-3 in large amounts of data is expensive. So we used the generated summaries as an input for generating some summarization models. So I wanted to add that. And also, when we were developing named entity recognition system, we were manually labeling it. It was really good to have in early stages system to predict the labels, and then as you were annotator, you could see where the model made the most errors. So I would suggest, if you are labeling dataset, do the training of the model as soon as possible and use it to make predictions while labeling.
Yeah, thank you very much for your points. A few words about first point. Yeah, so it could be. By the way, we did for some of our projects similar things, and I want to add that it's not only NLP. So we did in past. We didn't finish this project yet, but we are working on this. We did interesting situation that we have really biased label data set, and this particular task was about face segmentation, and we have data set which was shifted to some specific races, and we don't have enough data, and we use specific game engines like Unreal to generate, let's say, faces of with good, let's say, distribution of races, nationalities, and so on, and afterward retrain this model on the top of this, and using this approach, we can achieve better result because now our model can, let's say, recognize some specific points which typical for, let's say, samples of people which were underrepresented of our initial data set. So it's valid point again. About second one, I didn't dive deep in last case, but we did similar things. So we trained initial model and use this to improve our, let's say, labeling. So
yeah, it speeds you up in the end.
Yeah.
As a labeler.
Yeah. So we did similar trick, but maybe not in that frequent, but still we have our initial model and we use this model to, let's say, support guys who work on annotation. But for this specifically case, we can do something like, let's give this data and provide to mechanical Turk on similar solution, because this data is kind of under NDA and you can use only expert domain help, and they are kind of busy guys. They from financial domain, so it's really expensive to use their help on daily basis. Because of that, actually, this story with label propagation supports us a lot, because they can't label for us 5,000 document, but 200 for easy. And 200 it gave us significant result just because we use really specific documents which can be used for labeling propagation after. But thank you for your question. Yeah.
Thanks to you. Great talk.
Thank you. Any other questions? Yes, there's another one.
Hi. So you mentioned basically that the budget for labeling wasn't there. And just a question about that, because I mean, I've seen many different projects that it turned out to be much more expensive to have engineers deal with data which wasn't adequate. So it turned out that it was actually cheaper to label, but you don't always know that. So how do you get to decide where do you think that it makes sense to go with less labeled data? So maybe some experiences. How do you tell your client, okay, we are going like this and we're not labeling, and why? So maybe just expand on that.
Yeah, thank you for the question. It's really valid because for most of the cases, we prefer to use annotation team because it's, let's say, a less costly comparing to using developers. But sometimes you can share this data. It's many points like NDA and so on. Sometimes annotators should be domain experts in really specific task. So if you're talking about cat versus dog, anyone could do this. But if we are talking about some specific loan document and maybe bank agent, it could be relatively easy. But if you're talking about specific facility or issuer, it could be hard for not prepared people to do this labeling. And because of that, if you're talking about typical task, yeah, it's easier to do labeling. If you're talking about not typical task, domain specific, it would be sometimes much easier to do some tricks than to, let's say, load this work to really expensive guys who actually deep domain expert in specific domain like financial or similar. But yeah,
Yeah, thanks.
Oftenly we communicate about money, what would be more costly. So it's business actually.
Thank you. So that'll be it. Sergei, thank you very much for the
Yeah.
presentation.
Okay.